level and in a distribution network, and also what it looks like at a building level as well. So Young Energy Performance Group for 2021. So yeah, excited to kick this one off. And today we'll be discussing demand side response, and our speakers will go into more specifics on the technology and how it could be utilized at a high level and in a distribution network, and also what it looks like at a building level as well. So in terms of, for anyone that is not aware of who we are, we're the CIBSE Young Energy Performance Group, and we're a collective of young energy professionals, a mixture of engineers, architects, consultants, and contractors, all focused on, improving building energy performance, and also in line with that, professional development, focusing on young professionals coming into the building services sector. We've recently had our AGM, so we welcomed a lot of new members to the group. So we're looking at a really productive year where we'll have a lot of events like this one tonight. So yeah, keep an eye on LinkedIn for all the upcoming events. In terms of our specific mission, we're here to get together to improve the energy performance of buildings and reduce their carbon footprint. And like I mentioned, reach out to young professionals aspiring to join the building services industry, supporting them in their professional development towards achieving chartered status or whatever kind of industry recognition body they want to go through, and provide just a forum for discussion and enabling networking opportunities and collaboration amongst members, amongst different groups within that the building services sector. And this is an example of some of the events that we used to have when the world was open. So we're really, hoping to kick this off and have some more in-person events in the near future. Touch wood. In terms of the event today, as I mentioned, we're discussing demand side response. And there's, I guess, the two key questions that our speakers today will address is firstly, given that we're moving towards an electrically powered future to achieve our net zero targets, can our current grids accommodate the emerging demand in electricity, as well as the anticipated unpredictability from increased renewable generation? And how will demand side response, I guess, feed into that and help us achieve that? And then at a more building level, more granular level, with the increased uptake of storage solutions on-site, as well as stuff like on-site generation, how can these be utilized and integrated with the grid to decrease electricity bills, manage peak electrical loads, and just overall improve the energy performance of a building? Our two speakers today are Sam Doe from UKPN, a smart grid flexibility engineer, and Sam will be discussing a topic based around the benefits of UKPN's flexibility services in managing distribution networks, and also how this feeds into facilitating that net zero transition. Our second speaker today is David Watkin from Solar Edge. And he'll be looking at that more granular level at a building and kind of what products Solar Edge provide, and to improve, I guess, the integration with demand side response at a building level, and some interesting stuff around critical power integration as well. And can I just say, if you have any questions, please just put them in the meeting chat, and we will address them at the end. Great. Sam, if you wanted to share your screen.
Thank you, Gavin. Yeah, so first of all, thanks for having me here. As Gavin said, my name's Sam Doe, and I'm a flexibility engineer at UK Power Networks, where I've been for the last 5 years, and I work in the smart grid development team And I'm going to be talking about what flexibility services is, particularly from the perspective of the distribution network, and also emphasizing the opportunity that's available for providers of flexibility to participate. So a bit about the company, if you're not familiar. UK Power Networks owns and operates 3 of the 14 regulated electricity distribution networks in the UK. That includes London, the southeast, and the east of England, and we supply around a third of the GB population, about 19 million people. There's also 9.5 gigawatts of distributed generation connected onto our networks, which is also about a third of the total DG capacity in the UK. And as a company, our vision is to be an employer of choice, to be a respected and trusted corporate citizen, and to be sustainably cost efficient. And flexibility services really ticks the boxes of the last two visions, in that we want to be using flexibility services to enable the low carbon economy, whilst also minimizing the cost impact on consumers. So what is flexibility? So flexibility is, simply put, the ability of an energy asset or resource to be able to change its generation or consumption in response to some sort of signal. And that signal could be a price signal, or it could be an explicit instruction from the distribution network telling the operator to turn on the generator, or to turn off or turn down the consumption. So the generator or consumer are required to respond within a certain time frame and to be able to sustain that delivery for a period of time. And that depends on the characteristics of the asset, but also depends on the specific requirements of the service. So I'll talk a bit later about what types of services we're procuring. But generally speaking, we're looking for a solution that can respond within 30 minutes from an explicit instruction from us, and to be able to sustain it for at least 30 minutes. So examples of types of solutions that can provide flexibility services include distributed generation. So, for example, we've contracted with a gas genset, and that can provide an export of electricity onto the network when we ask for it. Another type of solution is energy storage, which can obviously increase the export onto the network, as well as reducing their consumption. And a famous example of a grid scale energy storage device is the one that we developed as part of an Ofgem funded innovation project at Leighton Buzzard, and that was in our eastern area. It's at the time it was the biggest battery in the UK, 6 megawatts, 10 megawatt hour, and it was used to demonstrate the potential and capability of distributed energy resources to bring benefits to the system. And in this particular case, the battery was able to defer a capital expenditure on upgrading the network. Another example of energy storage is a contract that we recently offered, whereby a provider has installed batteries in people's homes, and when we asked that provider to provide the service, they discharge the batteries remotely, which reduces the net demand on the network. And of course, demand side response, obviously maybe more relevant for people on the call today. And there's a wide variety of types of solutions of how this can be delivered. It could be, for example, turning down the charging of electric vehicles. It could be shifting it. It could be turning off your refrigeration. It could be reducing your heating load. And it could be all controlled and managed through the your building management system. And the other thing I wanted to mention is aggregation, which is a combination of all of the above. It is a grouping together of multiple assets, which could be within the same site or it could be across multiple sites. And that grouping is then provided to the distribution network and is controllable as a single point of effectively like a virtual power plant. So in terms of how does the DSO actually send an instruction? There's broadly two ways in which an operator of an energy resource can participate. So you could come to us directly and be given a contract. We would send an instruction via phone, email, or through a cloud-based API instruction if your building management system is able to automate the delivery. Or you could go via what's called an aggregator. An aggregator is effectively a third-party company which may install some additional devices on site, and that could be control and metering equipment, and so that they can dispatch the resources remotely, and they provide the interface with us as a distribution system operator. As a DSO, we don't require any installation of devices on your site, but we just require that you are able to provide data, metering data, and to be able to control the delivery on instruction from us. So why do we need flexibility? So obviously the energy industry is changing and has changed significantly over recent times, and will only accelerate in the near future. We've seen a lot of generation connecting onto our networks, particularly renewable generation, and we're also seeing an increase and acceleration in the uptake of electric vehicles, and obviously as a distribution network operator, we want to enable that transition to a low carbon economy, whilst also minimizing the cost of the consumers, as I mentioned earlier. And flexibility is one of the key tools as a distribution system operator that allows us to achieve that objective by effectively being smarter in how we invest in the network, and also being smarter in how we operate the network. So this schematic shows how flexibility can be used to support the distribution network. So this is a, say, example substation, and the dotted line there is a load profile. And as you can see, there is a network limit, which is the red line. And when the demand of the peak demand starts to reach or exceed the limitation of the network, traditionally we would go out and reinforce the network, and that could be uprating the cables or replacing the transformers. But an alternative to doing that is to contract with flexibility services, which is a resource that can reduce demand on the network at particular times of the day, and thereby avoid or defer that reinforcement. So the way we actually do that is we would use forecasts to identify when the peak may occur, and we call that the service window. It could be from November to February, from 4 to 6 p.m., for example, where you have to be available. And when we actually have this occurring, the peak demand breaching the limitation, we would send an instruction for you to deliver the service. So this is obviously just a schematic, but if you want to know more, we have published our distribution future energy scenarios, which is a forecast of the energy pathways. And there's 4 different scenarios here out to 2050 within our license areas of how low carbon technology uptake will be seen over the coming years. And there's a nice interactive map that you can find on our website, where you can select the different types of technologies and see how that's changing. And that may change based on, for example, the level of engagement from individuals as to whether they want to adopt electric vehicles or electrification of heating, or it could be driven primarily by a centralized initiatives such as low carbon hydrogen networks. So we use those forecasts to identify substations or areas on the network where there is expected to be a need to reinforce the network in future. So we identify those locations, and then we publish it to the marketplace, whereby they can view where these locations are, and if they have assets in that locations, or even if they could install assets in those locations, there's the potential to provide services. And I'll show you in a moment how you might be able to do that. So as just to give you context to flexibility services at the distribution level, is a relatively new thing for us. Flexibility services, of course, has been around for some time. It is essentially inherent in the energy markets, where generators and suppliers are responding to pricing signals. Also, National Grid, as the electricity system operator, they procure these sorts of services and have done for quite some time. And you may be familiar with the types of services they buy, such as frequency response, which is used to manage supply and demand to keep system frequency at 50 hertz, or they procure reserve services to provide additional generation capacity when it's needed. But for us, it's quite a new thing. So back in 2017, we consulted on the strategy towards evolving into a distribution system operator. And in that consultation, we identified flexibility as one of the key priorities. In 2018, we published our flexibility roadmap, which is a forward look of how we would do it, how we would get there, and we set out how we would use flexibility services for what applications on the network, what sorts of products we would buy, and how we would engage with stakeholders to make it a reality. And to where we are now is we are working collaboratively with all the other distribution network operators, with the National Grid as the electricity system operator, as well as the wider industry, on standardizing and harmonizing the approach, particularly on flexibility, but also in other areas as well, to work towards a more coordinated and efficient whole electricity system. So all of these documents are available on our website if you want to learn more. So as I mentioned earlier, after we've identified the locations where we have a potential need for flexibility services, we would publish it onto a public accessible map. And the one we're using is Piccolo Flex. So Piccolo Flex, if you wanted to go on there, it's piccoloflex.com, where we would publicize the locations on the network where we might have a need. And we encourage providers to go on there to register a company, to upload their assets. And if they have assets that fall within those locations, then there's potential to provide the service. And then we would go through the procurement process to establish whether technically that asset is able, and also run the tender where you submit a price, etc. So currently we don't have our sites on the Piccolo platform because we're in the process of completing our tender. So that's just hidden for now, but in due course, we're looking to put some more sites back on. So why should you participate? In short, there is the opportunity for additional revenue streams, and we offer a very competitive price. In fact, we publish the sorts of prices on our websites ahead of each tender. You can also look at the previously accepted contracts. It's also on our website. You also don't have to be that big, so you only need to be at least provide at least 10 kilowatts, and that doesn't have to be from a single site. It could be a combination of sites, and a capacity. When I say 10 kilowatts, what I mean is a flexible capacity, being able to change your consumption or generation by at least 10 kilowatts. And the other important thing to mention is that we're open to existing and planned assets. So if you have existing assets, that's great. But also if you have solutions that you want to install, it could be an upgrading of your building management system in order to control your assets, then that's great too. And we offer a range of contract lengths from 1 year up to 7 years. So, for example, if you wanted revenue certainty, you could go for the 7-year contracts in order to justify the business case for a particular investment to build in the flexibility capability. Likewise, if you have an existing asset, you may be more interested in playing in sort of shorter term periods of time. So this is quite a high level what sorts of products we're procuring. So we have adopted these standardized product names, and all DNOs have used these product names as well. So the products are called Secure, Sustain, and Dynamic. The Secure product is the product that we use to manage peak load on the high voltage networks. And it's a forward procurement, forward commitment, usually at least 6 months ahead. So we run a tender in advance, and if you're successful, then you have quite a long lead time to prepare and develop your solution. We pay an availability and utilization. What that means is that, as I mentioned earlier, we'll specify a service window, effectively a time period where you are expected to be available to respond to an instruction. And for that period, you'll be paid a standby payment. That's the availability. And if you are instructed by us closer to real time, then you'll be paid a utilization payment for the energy that you have delivered. The other product is Sustain, and that's used to manage the peak loading on the low voltage substation. And the commitment is closer to delivery, so it's that month ahead. You're paid a fixed service fee, which is a little bit different to Secure. And you are effectively scheduled, so you don't need to respond to a real-time or close to real-time instruction. You'd know a month ahead when you need to run, and you just need to run, provide the service then. The Dynamic is used to manage both high voltages and lower voltages, and it's an optional service. So the intent of that product is that closer to real time, we'd go to you and we'd ask you to whether you'd like to provide a service based on a given price that's been pre-agreed, and you can say yes or no. But if you say yes, then you receive the utilization payments. So this slide gives you some background in terms of what we've done in the past. So in our last tender in the summer of last year, we awarded contracts up to £14 million, up to 123 megawatts of capacity, flexible capacity, across 57 of the locations, of which 15 were on our lower voltage networks, which was at the time the world first for any DNO. And this, if you see in one of our other slides, this is a incremental increase year on year to what we've been doing. So every year we're trying to publish more sites, more locations, and we're awarding more contracts. So the DSO flexibility is very much going to be to stay, and the opportunities is only going to increase. So how do you get involved? So the basic process is we publicize the locations on our on the Piccolo Flex platform. We also publish the tender documentation on our website, which is smartgrid.ukpowernetworks.co.uk. And you can, as I mentioned earlier, you can register yourself onto Piccolo Flex and upload the locations of your assets. If those assets fall within the areas that we're looking at, then you would be you'd be allowed to participate. So you would submit a pre-qualification questionnaire, which gives a bit more detail, and then we would assess that to see if you're technically capable and whether your connection allows it. And if that looks good, then you're allowed to participate in the tender, whereby you would submit a price and a volume, and if that is a competitive offer, then you'll be awarded a contract, and then you can start based on when the tender period is usually the first 2 years ahead. So you can start in the following winter, the following summer, or for the subsequent winter, subsequent summer. So that's all I really wanted to cover today. You can find out more by getting in touch. Our email address is there, flexibility@ukpowernetworks.co.uk. Of course, you can contact me directly. It's sam.doe@ukpowernetworks.co.uk. You can also go onto our website. But as you can see, we're quite a small team, the energy markets team within Smart Grid Development. And so, yeah, if you have any questions, we're a friendly bunch and we don't bite. And I'll hand you back to Gavin.
Thanks, Sam, for that. Great. And David, do you want to share your screen?
Yes, thank you. One moment. Right. So you should be able to see my screen now. So thank you for joining us this evening. I will introduce you to SolarEdge, its products, and what it can be used for in demand response, and then generally move on to future trends, how we're developing things for the future. And as with Sam, you will get these slides post the event, and you can post chat questions, and we'll go through them afterwards. So I'll make a start. Second. We have to have this in here as a corporate company. It's just our disclaimer. So that will be in your package, but we won't read it now. So this is a quick introduction to SolarEdge. Basically, we're a smart energy provider. This circle here shows all our different areas and sectors. Personally, I work in the critical power division, and that mainly means UPS systems and everything to do with keeping critical systems going. But in the UK, we work very closely with our solar team. They're in the same building. So they're doing all the inverters, smart modules, monitoring, etc. And then further out through the group, we have Qualcomm, who make lithium batteries. They're the 5th largest manufacturer in the world. And in Italy, we have an EV powertrain solutions company. They've recently been awarded large contract with Fiat to make light goods vehicles fully electric. So you can see we've got a broad spectrum of products and services, and they all kind of tie together into a smart energy solution. Qualcomm, they do ESS, that's standby storage, very large containers. So yeah, that's us in a very quick one-page format. To give you an indication of the size of the company, they're the largest solar inverter company in the world, over 3,400 employees, 24 gigawatts plus supplied around the world, and a very rapidly growing company. SolarEdge only started in 2006, but we've already increasing every year. They're market-leading products in a rapidly growing market, basically. Many patents and unique products. So if I move you towards my particular area of expertise, and that is in the world of UPS systems. Just to explain a UPS system, then later we're going to see how they can be used in demand response. So if we look at the schematic of a UPS system, this is much simplified, but it has all the important elements within it. You have a rectifier, so the power comes in, it's AC, it's rectified to DC. DC is used to do two things. It's used to, one, charge the battery, and two, power the inverter. The inverter converts the DC, back to AC. So on your output, you've got a perfect waveform. Now you can see that if the mains fails, the battery is already supplying the inverter. So the inverter will just carry on without any interruption or any break in power, as long as the battery lasts. And then finally, we have a static switch. That's there as a backup, as a bypass. The inverter is overloaded or fails, the static switch will close without any break, so the load will continue to operate in bypass mode. And this is a very simplified building circuit. So power would come into a building, it would go to a transformer or main LV panel. On that LV panel, you would have non-critical loads directly fed from the mains. You may have a generator, but you would definitely have a UPS feeding the critical loads. Normally IT, but can be anything. And obviously the UPS has a battery to keep things going. So that explains the basics of a UPS system. But obviously there's a lot of synergy between UPS systems and solar energy inverters, because they all contain the same elements. You have DC to DC converters, DC to AC converters called an inverter, AC to DC is your rectifier. They all have battery packs. Key to success is the management software and the communication ability of the devices. You can see there they're all modular as well. I'll move on to that now. Being modular, we find we can offer certain key advantages. In a PV system, on every panel there is a power optimizer. So that particular panel is optimized in its output. It doesn't, if it's low, if it's in the shade, it doesn't affect with the rest of the string. And the power optimizer is also intelligent. It goes back to a central control system, so the user can see the performance of every panel, even if they've got, 1,000 panels. In the world of UPS, being modular increases your uptime. If one of the power module fails, it's not a disaster. The whole machine doesn't shut down; it just carries on because you have redundancy built into the system. and very low MTTR, mean time to repair. You can just swap these modules in seconds. In the world of PV, having this modular approach means lower operating and maintenance costs. And in the world of UPS, it means you can start at X load and you can grow up to Y. So your initial investment can be lower. And that also increases your efficiency, which reduces, building consumption. i.e., if you had a huge UPS, because you were worried about sizing, you'd be burning a lot of unnecessary electricity. So modular systems help a lot there as well. It's good for the safety in PV. You can remotely turn on and off a panel, so you're going to be safe working on systems before you start. The world of UPS, it reduces the risk of downtime. The systems would always stay online, even if one module fails. And in our latest generation systems, everything is modular, even the static switch, and that can be replaced in a matter of minutes. The flexibility overall, that's just the beauty, really. You can start a system, and it can grow or it can get larger, smaller as time goes on. So it takes a lot of stress away. So this is showing you that, the evolution basically of systems. Looking at UPS, they used to be in the old days like a huge system, size of a room. It's now come down to the size of a filing cabinet, and UPS became modular several years ago, but recently they're kind of true modular. Everything is changeable on them, and no one part of the UPS can result in the load going down. So that's that's the key to modular solutions. What it means in summary is higher uptime, but most of all, it's greater clients' satisfaction and peace of mind. In the old days, when if a UPS failed, we would get a very angry and concerned phone call to say your UPS is down, everything's gone down, it's a disaster. You must come in, you must come here within an hour. But now with modular systems, we just get a call saying, oh, one of the modules has gone down. Come when you can to fix it. We've still got redundancy left on the other 10 modules in the system, so no stress. So it's very good for that. Obviously improved fault resilience. Reduced electrical swap. In the old days, you had people inside these UPS systems, which have very high AC and DC voltages. But now the engineers just swap a module. So their risk of electrical shock is a lot less. Low MTTR is very key. Obviously, it's a critical system. You want it to be up and running all the time. So if you can fix it very quickly, that's a big bonus. And it's a good way to invest. It's the most efficient way for redundancy, gives you scalability, and you can easily upgrade the system if you made a mistake at day one. So all these systems, a UPS, it can be the best UPS in the world, it can be 100 times redundant, but they all need batteries. And for many years, UPS have only come really with lead acid batteries, occasionally with some of these other battery technologies. They all have pros and they all have cons. So the moral of the story is you must select the correct battery for your application. This doesn't include lithium. Lithium is the most recent innovation in the world of power, high power batteries. Everyone has a lithium battery in their phone, nowadays in their car as well. But if you went back 10 years ago, they didn't have any large power lithium batteries, but now they do. And these are the key advantages of lithium. It's about a third of the size of VRLA. It's very lightweight. It's very good at giving out high amount of power immediately in a short duration, which, as we see later, is very good when you're looking at peat lopping and peat shaving applications. They've got a long cycle life, and that is key. If you're working on demand response and you're cycling your systems up and down, discharging and recharging, you know, VRLA is very poor. It can only do about 300 cycles, whereas lithium is over 3,000. So it's almost a must for cyclic applications. And they last 2 or 3 times longer as well. So you have to consider that when you're looking at total cost of ownership, because you know, they might cost twice as much, but they will last twice as long. They're better at temperature range, lower maintenance, and they don't release any hydrogen. This is a quick view of one of our battery cabinets. One key thing to mention on lithium batteries is they include battery monitoring as standard down to cell level. So each one of these is a module that contains several cells. It's like a BMS interface on the front of it. It monitors the temperature and voltage and current of every cell, and that then all feeds up to the central control system and then is outputted on an Ethernet port. So your local user can immediately know the exact status of every cell within their lithium battery system. On VRLA, that was an expensive option that often costs more than the battery itself. So this is a very large added benefit. So just to recap on lithium, much higher energy density, up to 5 times longer cycle life. It's actually 10 times longer in most applications now. That needs to be updated. No degradation with shallow cycles. When it does fail, it doesn't fail open circuit like VRLA, so you still have a circuit, which is very good. No hydrogen to deal with, and you get all this battery monitoring as standard. So I'm now moving on to smart energy and trends for the future. Some of this Sam has already covered, but I think it's worth reinforcing from a different angle. So the grid is really facing extreme pressures and very fast changes at the moment. With all the renewables on the grid, they're very good, of course, in reducing carbon, but they're not very stable, i.e. when the sun goes in, the wind stops, the power goes off. There are ways to combat that, as we'll see soon. One of those is energy storage on solar. It's becoming more and more in use, because quite often people have the solar, they don't want the power during the day. They want it, they want it in the peak times in the evenings. So, in the winter it's dark at 4 o'clock. So that's becoming more and more widely spread. E-mobility, more and more people charging cars. If everyone had an electric car tomorrow, we'd all be in darkness because there isn't enough power. So that's key to managing that. There's lots of devices now, increased connectivity and, the Internet of Things. In the future, we may be driving cars along the road and they're actually controlled by 5G networks, and that's kind of the edge of things. And power is critical there. But yeah, and there's more and more industries, high-tech industries, that require very constant, very clean power. One good example, which is a sad reflection of our times, is kind of research and development into vaccines and things of this nature, and drug research. That market sector is exploding at the moment. And talking with the people I meet, these guys have experiments that go on for 3 months. And if they have a power cut after, 2 months and 29 days, they lose all the data and they have to start all again. So that shows you the level of and the need for critical power. So basically, we're moving from a centralized grid where you just have one huge or several huge power stations and everyone just consuming power. We're moving to a distributed grid where you still have the power stations, of course, but there's more and more local, prosumers and people generating energy back to the grid, and a vast network of interfaces, and that's all got to be controlled and it's all got to operate seamlessly, because it's very important, this demand response, because the grid in this country, for example, they didn't sign off the nuclear power stations. There was a huge delay of something like 10, 15 years even. So we're operating on only a few percent spare capacity, and that's why this is key, and it's a growing demand basically for demand response. And SolarEdge as a group recognizes, these changes that we're all facing, not just in this country but over the globe. And this slide comes from the CEO of SolarEdge, that we recognize this and we want to be at the forefront of those changes and have the products and solutions to help people. So moving back to UPS and our concept for a hybrid UPS. So the good thing about a UPS is that it obviously has batteries. You can turn off the power to it. You don't get any break in power. It's a double conversion VFI, voltage frequency independent machine. So you can instantly turn off the power to it and it will just carry on running. Now, typically people have batteries for say 5, 10, 15 minutes. So they would have a power cut. If there was still a power cut after 5 minutes, they would do a controlled shutdown. Now we can easily increase the size of that battery to say 1 hour and make it a lithium battery. And then, as Sam said earlier, he requires power, for 30 minutes at a time. So if we have a 1 hour battery, we can comfortably use 30 minutes of it for grid services, and then we still have 30 minutes left, for example, for critical power. So we would never, using this UPS system, we would never dig into the critical power via software and controls. We would always keep within the window for grid services. So your client could be assured that although, yes, the UPS is being used, the power is always constant. And, one of the key benefits is the customer gets good payback for having these functions. Sam earlier mentioned that you need response within 30 minutes. Well, these UPS systems can respond in, as long as it takes to a few milliseconds time it takes to switch on a switch. They can just instantly turn off their rectifier, and then basically they're invisible on the grid. Also, the great thing is because we're not exporting power back to the grid, we don't need all the complications of G99 relays and all that testing. So we're basically just turning off a switch in simple terms, and we can do that very quick. And I think frequency response is where they need things done very quickly. So moving on, I'm coming towards the end now. Sam detailed, peak lopping or peak shaving. This peak may be from the network. The network may You know, UKPN may have too much power, so they may want us to switch on to help them. But equally, this can be from the client's end as well. They may have a limit on their power, their maximum consumption. If they go over it, they get charged a lot of money. So in those periods, we could switch our UPS to battery, or we could switch on our inverters from our solar energy storage to avoid them going over that limit. Now that's called peak lopping. It avoids you going over a limit. And, you know, peak shaving is another word for it. You know, you can take out those peaks. One example I had was working with an MRI machine where at huge peaks, which meant if the customer had to pay for those peaks, their electricity bill was monumental, even though they're only short duration peaks. So, you know, the UPS can be used to smooth out those peaks and keep continual power going. So it's very good. I've touched on frequency response. UPS can be very fast acting for that. And obviously general demand response. You know, so in the world of solar edge, we've got ESS systems, we've got PV panels feeding into batteries, we've got inverters. So all of these can be used by clients, aggregators, UKPN, you name it, basically, everyone can use them. So we're wrapping up now, and I've really jumped through these topics, really only touched on them. We have webinars on certain subjects that you'd be more than welcome to sign up for. So it's really just to keep in touch, you know, log on, follow us. And on LinkedIn, we've got a good page. If you follow us on there, you'll be updated on new products, webinars, etc. My contact details are there. You'll be getting a copy of these slides. These are the key takeaways. Obviously, we can help you with smart energy and critical power. Modular design ethos is key for success, we feel. You know, we get so much praise from our customers on how modular has saved them in many times. Distributed grid is the future. There's no doubt about that. We're heading there now. Grid support, it's needed right now, and it's going to grow. There's going to be more grid support required. So this is a growing market. UKPN, DNOs and aggregators have numerous schemes. So if one scheme doesn't suit your client, you can probably find another scheme that does. And the client will not only receive financial benefits, but they'll also receive resilience benefits. Because in my example of the UPS with a 1 hour battery, if they weren't using grid services and there was a power cut, they would have a 1 hour battery rather than the 5 or 10 minutes that they would have had normally. And the revenue they will get will more than pay for that 1 hour battery. So it is really one of these rare win-win situations, I feel. And finally, I'd just like to say, keep your eyes out on Solar Edge and the future synergy between critical power and energy storage, because we're looking at that closely. Really, that's it from myself. So thanks for listening, and I will hand you back to Gavin now.
Thanks very much, David. That was really, really interesting. And Sam as well. Both really interesting presentations. Opening the floor to questions now. So I've got a question from probably for Sam, I think. So a question regarding, if you take up flexibility measures, does this still mean that you have to design for non-flexible peak for development electrical infrastructure? So does flexibility services account for that already, or do you have to account for these peaks when designing electrical infrastructure as well?
Yeah, so good question. So we see flexibility and non-flexible assets as part of the solution. So they both play a role. So before increasing the capacity of the network, what we want to do is to do effectively a cost-benefit analysis and see what is the most economic and efficient solution. Whether we should go with a flexible solution or an upgrading of the network. It might be that flexibility can be used to give us some optionality. So because load growth is uncertain, it allows us to effectively postpone the decision until the load growth is certain, and then we can upgrade the network. So I think both are key parts of the solution. As a distribution network operator, historically we've been more on the increasing the network infrastructure first, but as we move towards becoming more of a system operator, that would entail that we shift a lot of the decisions onto the operations of the network, similar to I guess the National Grid as a system operator, whereby they manage any potential network issues using flexibility services, and they have various assessments, I suppose, before then to determine what is the most economic solution. Do they need to upgrade the network, or can they manage it economically and efficiently and safely using flexible solutions?
Great, cheers. Hope that answers the question. We have another question regarding, I think, one of your slides, Sam, around your distribution future energy scenarios. I think those 4 kind of levels of ambition associated with the grid. Is there, in your opinion, is there any other kind of possibilities that would feed into this that maybe wouldn't have been considered? Or do you have any other comments around that?
Yeah, I would say that the energy landscape is very dynamic and changing very quickly. So and that's why we need to reassess the forecasts on a regular basis. So we publish it every year. So do other DNOs, and so does National Grid. And the development of the scenarios is not done in isolation. We do a lot of engagement with local councils and stakeholders to inform those scenarios. The scenarios are really just plausible energy pathways. Of course, there might be lots of variants to those pathways, but I think they're trying to represent slightly different approaches and outcomes, such as a slow uptake of low carbon technologies, because perhaps we prioritize cost efficiency over meeting the low the carbon commitments, or at the other end we could accelerate and reach net zero carbon before 2050, and those are in the way we've modeled the growth scenarios. Great.
Yes. Nice. I think another question around the qualification requirements for aggregators. So kind of what do they need? I think you might have touched on it, but just to reiterate, from an aggregator perspective, what do they need to qualify to participate in the flexibility market?
Yeah, maybe I need to qualify that question a little bit. In terms of is it in terms of the aggregator specifically over other types of providers? But I suppose answering generally, all providers of flexibility are has to go through the pre-qualification. So we'll check that they're a supplier, a vendor that is able to deliver the service. Do they have previous experience? Do they have the technical capability to control these assets? So it's And if they have existing assets, are those existing assets already set up, or do they need to do more additional work to the sites to make it ready? So part of the pre-qualification involves the provider submitting a delivery plan. So we would assess what they intend to do and make a judgment on whether that looks it looks like a reasonable proposition.
Mm-hmm. Great, thanks, Sam. I think the next few questions are for David's presentation. So we have a question here around lithium in general. So lithium ion batteries, sorry. So basically just looking at how widely available is the technology at the moment within your market. I think maybe also a question around is there what's the future look like for lithium as well from a resource perspective?
Yes, thank you. Yeah. As we know, lithium batteries are very widely used in vehicles, of course. So that side of the lithium battery world is growing hugely. In the world of UPS systems, they probably only represent about 5% of the UPSs that are out there. Most of them have VRLA batteries, but the demands are growing. We're getting more and more inquiries for lithium batteries, and so yeah, I mean, I see the costs are coming down, and the costs will continue to come down as there's a huge amount of production, mainly in the vehicle market. So the costs will come down. I do think they are the future. And with regard to sustainability, it's that there are rare metals used in some lithium batteries, not all. Cobalt is the rarest metal, but not all lithium technologies actually use that. And the other parts inside the battery are very, common items. But of course, you're mining the earth for product. So, but yeah, so as long as they can eliminate cobalt, and which kind of half of them already have, then they're a lot more sustainable than VRLA, because there's a lot less volume of the things being made, and in the future they will all be recycled like VRLA is now. So I think that's as much as I can answer at the moment.
So in terms of the future for recycling lithium ion, that's still a big a market. That market's going to grow as well, quite significantly.
Recycling, yes, yeah, it's very immature, the lithium recycling market, and that there is talk of a second life for like lithium batteries in energy storage. I won't go into too much depth, but there is talk that when they come out of a vehicle, obviously they're degraded, but they could be used not in a UPS where it's critical. They could be used in an energy storage system. So they may even have second life, the lithium batteries. But all these things are quite new and developing, so there's no kind of black and white answer at the moment. So yeah, I think that's that one.
And in terms of the different requirements for clients in different locations in the UK and in worldwide, do you find that there's a difference? Is there different needs in each of these cities? London, I know, has probably different requirements in terms of compared to other cities in the UK in relation to critical cooling and UPS systems.
I find obviously London has the city and other very important establishments, but so does the rest of the country as well. So I think the only thing different in London is to do with emissions and space. no one has room for like a generator in London, really, or not. So in London, there's more call for like power systems working on batteries, whereas in more rural areas, they may use a generator. But we haven't mentioned it. I'd like to point out that you're not allowed to use diesel generators for grid services now, unless they have some very expensive modifications on them to clean the engine. It was outlawed 2 or 3 years ago. I think it's the medium combustion plant directive, if anyone wants to look up that. Sam mentioned gas generators. They're okay, I believe, but diesel generators are frowned upon now. Just to put it out there, yeah.
Yeah, and you mentioned, I guess, a key benefit between lead acid and UPS and lithium ion batteries being the operating temperature. So does that I guess have knock-on effects in terms of cost savings from reduced cooling, and can you downsize those systems quite considerably, or do they need cooling at all?
Yeah, well, the batteries don't actually really generate any significant heat themselves. But going back to your first point, yes, lithium batteries can operate, depends on the exact model, but they can operate up to like 28 degrees C without any degradation, whereas VRLA batteries have to be kept at 20 degrees. So obviously, you've got 8 degrees where you could potentially get a lot of free cooling with those 8 degrees in a typical building, which saves consumption, which saves carbon. And if they do go above that temperature, they don't fall off the cliff like VRLA do. VRLA, if you go up to 35, for example, you get like less than a third of the life from the battery. So yeah, I hope that answers that one.
Thanks. Yeah, that's really interesting. And I think one final question just around incentives and I guess this is kind of, do you think is there any kind of incentives out there from at a government level for kind of upgrading to this kind of technology, or do you think it needs more push to enable customers to participate, or does it need to be incentivized? I guess maybe that'd be the question.
Yeah, I mean, obviously I wish it was incentivized, but well, I mean, grid services there are incentives for that, but obviously kind of retrofitting lithium to a customer is quite expensive. But for any new projects, it would be simple to do, like a cost exercise of this system with the 1 hour lithium versus a more basic system, and you could get a forecast from someone like Sam or an aggregator on your revenue stream. So you might find, yes, you have to spend more at day one, but after 1 or 2 years you would become neutral, and then your remaining 12 years of the system you would be making a revenue. So there are incentives. I wish there were more incentives, especially for solar, because you often find people just have the token gesture solar on their roof when they could fill the whole roof. They could do a lot with that energy. So yeah, I think in general the government need more incentives for this, really. And if they're serious about their pledges, then surely they must hopefully release some soon. But so yeah,
we'll watch that space.
That's my personal feeling. Yeah.
Great. Well, thanks, David. That concludes all of the questions. So I think we'll leave it there. So David, thank you very much for your time today, and I hope everyone got enjoyed the presentation, and if you feel like you want to get more involved with CIBSE YPG, or kind of stay in touch on our LinkedIn to look at more up and coming events, and yeah, we'll circulate slides and the CPD certificates as well as part of this. So, and yeah, feel free to get in touch with Sam or David if any of the points from these presentations resonated with any of you. Thank you very much, everyone. Have a great evening.
Have a good evening. Bye-bye.